warahmatullahi wabarakatuh, and hi. In this video, we are going to summarize laboratory experiment for experiment 2, which is capacitance by me, Nur Aina Tasha binti Musyarimain, Nur Salsabila binti Norizan, and Nur Ali Adriana binti Muhammad Izhan. There are two parts in this experiment. Now, I will explain about the part 1 for this experiment, which is capacitance. First, the link of PET simulation has been clicked and studied. The paper from the choice of dielectric in the menu on the right-hand side was selected. The dielectric is completely inserted inside the capacitor and the battery could be either connected or disconnected for this part. The values of the plate's area A, initially it should be the smallest possible distance between the plates D, initially it should be the largest possible, and corresponding capacitance was recorded. The plate's area was slowly increased and the corresponding capacitance was measured for 4 more times, and the result was recorded in table 1. The graph capacitance against the area is plotted. Then the area was restored. The separation between the plates was decreased slowly and the corresponding capacitance was measured for 4 times, and the result, along with the reciprocal of the separation, are recorded in table 2. And lastly, graph capacitance again, the reciprocal of the separation between the plates was plotted.
Next is results and analysis data for part 1, which is capacitance. This is the data for part 1. The results for table 1 is for area m square and capacitance C. The result for table 2 is for separation between two plates, the reciprocal of the separation between two plates, and capacitance. Next is analysis data for table 1. We need to plot the graph capacitance against area, and the result is directly proportional. After that, we need to find the slope of the graph by using the formula, and the slope the graph 1 is 3.075 multiplied by 10 to the power of negative 9. Next is analysis data for table 2. We need to plot the graph capacitance against reciprocal of the separation between the two plates, and the result is directly proportional too. After that, we need to find the slope of the graph by using the formula, and the slope for graph 2 is 3.450 multiplied by 10 to the power of negative 15.
Okay, next we move to the discussion of part 1. We have got that the crater of plate area, the charge that may be stored in there, is increased and the capacitance will increase too. Second, the crater reciprocal of separation between plates, the capacitance will increase too. In this experiment, we have noticed that the key theoretical value of paper in PHY simulation was stated is 3.5. Okay, for the conclusion part 1, we got that the capacitance of a parallel plate circuit is directly proportional to the plate area, and the capacitance of the parallel plate circuit is inversely proportional to the separation between the plates. The key experimental value in this experiment is 3.47 with the calculation below, and the percentage error in this experiment was 0.86% with the calculation below. I think that's all for the part 1 experiment. Okay, for the part 2 experiment entitled Effect of the Dielectric on the Capacitor. So the procedure in this part is, first, from procedure 1, the values of the plate's area and the plate separation was set up to the original, and the dielectric is removed completely from the capacitor. Second, the capacitance, charge, voltage, and energy meters were clicked on the right sidebar in PHY simulation. Third, the battery was connected and the battery voltage was set up to 1 volt. Therefore, the scale of some meters must be zoomed in to get the measured values effectively. 5. The dielectric was slowly inserted inside the capacitor. When the dielectric fills more space in the capacitor, the change of capacitance, charge, voltage between the plates, and energy stored by the capacitor were observed and recorded in the table 3. 6. The red electrode is connected on the plate with the positive charge, and the black electrode is connected to the negative charge. 7. Then the dielectric was removed entirely and the battery was disconnected. Step 5 was repeated and the changes in capacitance, charge, voltage between the plates, and energy stored by the capacitor were observed and recorded in Table 4.
Next is results and analysis data for part 2, which is effect of the dielectric on the capacitor. This is the final data if we connect the battery. This is the final data that we get if we disconnect the battery.
Next, for part 2 discussion, we got that the greater offset value, the change of capacitance charge and energy stored by the capacitor will decrease when we connect the battery. And when we disconnect the battery, the change of capacitance will decrease when the offset value was increased. Then, the voltage between the plates and the energy stored by the capacitor is directly proportional with the offset value. In this experiment also, we have the experimental error that is misreading data. So we have to make sure we check the data properly and we set up the fact simulation nicely. Okay, for the conclusion of part 2, we got that there are two properties of the electrical conductor proven. That is, free charges exist only on the surface of the conductor, and one more is conductor always allows the movement of electrons and ions in them. Second, we got that the changes on the dielectric could affect the value of charge, energy, and capacitance when we connected the battery. And when we disconnected the battery, the changes on dielectric affect the value of capacitance, voltage between the plates, and the energy stored by capacitor. And lastly, the conservation of charge refers to the fact that the overall quantity of electric charge in a system does not vary over time. Charged particles may be generated at the subatomic level, but only in pairs with equal positive and negative charge, such the overall quantity of charge stays constant. I think that's all from us. Thank you.